All right, hi you guys. So in the previous video from the final exam review, I went over number 46 and number 47. In this video, I'll be going over number 48 and 49, and then number 50 and 51 will be in the next video. I'll probably include number 52 in this one, but I'll let you guys know. Okay. All right, let me go ahead and save a picture of this and then erase this. Okay, so number 48, you're asked to solve for x, and you're given the equation 9 to the x plus 1 power equals 27. Okay. This one's actually a little bit interesting because you're going to need to use logs to undo exponents, which is a little bit hard to grasp at first. That's actually one way you can do it. For this one, it's a little bit easier because you can match bases. I'll go ahead and just show you both ways. So let's do method 1 in purple. Match bases when possible. Then match exponents to solve for x. Okay, so that's going to be our first method. Let's go ahead and just write in our second method. Method 2 is going to be to use logarithms to get variable x outside of the exponent spot. Okay, so then we'll solve for x. Okay. The advantage of method 2 is that it works no matter which type of problem you're solving. Method 1 can only be used if the bases can actually match up, okay, which we're going to find in a second. Okay, so let's start method 1. First thing to note is that 9 and 27 do share a common base, a base of 3. So we can write 9, and let's actually color code this a little bit. Okay, we can write 9 as 3 squared. It still has a power of x plus 1 on it. And then 27, we can write that as 3 cubed. And I can actually put that in good measure. All right, so then now what happens over on the left-hand side? Well, you're going to have your 3. That 2 is going to be multiplied by the x plus 1 because of our exponent rules. And then on the other side, we still have 3 to the 3rd power. Okay. When bases match, simply match the exponents and solve for x. Okay, so let me color code these exponents right quick. Okay, let me erase them first. So the exponent we have over here, it's 2 times x plus 1, the quantity, And over here on the right side, we have a 3 as the exponent. So bases match. Ignore the bases now. You just bring down the 2 times x plus 1 and set that equal to 3. Set exponent equal to exponent. All right, now this is a linear equation that we can solve. Okay, so we have 2x plus 2 equals 3. 2x equals 1. So x equals 1/2. Okay, we are going to check this. Does 9 to the 1/2 plus 1 power equal 27? Okay, well, add exponents here. That's going to be 1/2 plus 2/2. So that's 9 to the 3/2. And then just for good measure, there's ways that you can play around with this that are actually pretty fun, but you can just use a calculator just to make sure. 27 does come out to be 27. So this particular solution checks out. Okay. All right, so let me go ahead and save a picture of this, and I'm going to erase this bottom part here so we can go over method 2. Okay, method 2. Okay, so first things first, bring down your 9 to the x plus 1 equals 27. And leave yourself a little bit of space in front of both the 9 to the x plus 1 and the 27. So as a matter of fact, I'm going to give myself a little bit more room here on the right side. Okay, now I'm going to take the log of both sides. It doesn't matter which log I use. So typically you want to use log base 10, or you can use natural log if you feel most comfortable, the ln. You have a button for both in your calculator. They both work. So I'm going to just log both sides. Now on the left side, 9 to the x plus 1 is the argument for the log. And on the right side, 27 is the argument for the log. Okay. What is the purpose of doing that? So that we can use our log rules to bring the x plus 1 down to the front. Once we do that, the variable is outside of the exponent place, and then we'll just be evaluating log of a real number. So we'll get a real number from that. Okay, so next step, use power rule of log to bring x plus 1 down. So note it is still a factor, x plus 1. And then you're going to have your log of 9 left. On the right-hand side, you're going to have a log of 27. Okay, now in the next step, you want to try to isolate x, right? So remember, this log of 9 is just a number. So we're going to distribute, okay, in the next step. Okay, we save that. Let me go ahead and clear out this top portion so I have some more room. Okay, there we go. All right, so when we distribute, we wind up getting a little plus between here. We get x log 9 plus 1 times log 9, which is just log 9. And that is equal to log of 27 on the other side. Remember, you're trying to solve for x, so subtract log 9 from both sides. You have x log 9 equals log 27 minus log 9. Okay. Be very careful here because remember, this is actually going to be a log rule that you use to combine these. So x log 9 equals, this is going to be the quotient rule. Of log. So you're going to have log base 10, which we don't write that part, 27 over 9. Okay, let me start erasing some of this. You can see that matching bases is much easier to do if it's possible. There we go. All right, so let's continue. We have x log 9 equals log of 27 divide 9 is 3. Go ahead and divide out both sides by log 9 to isolate x. You have x equals log of 3 divided by log of 9. Which actually is a change of base formula. X equals log base 9 of 3. Okay, now if you were checking this in your calculator, you would want to plug this part in. So log of 3 divide log of 9, that's going to give you the 1/2. Okay. But just to bend your mind a little bit, remember how we were talking about exponential form? Manipulate this and see what x should be, right? Okay, so I have my base of 9 to the x power equaling 3. So x should actually be 1/2 because the square root of 9, which is 9 to the 1/2 power, is 3. Okay. So yeah, again, always go with the easiest methods for this type of problem. I would definitely say use method 1. I just like to give you both methods so that you understand when we start doing problems the longer way, why we have to do them that way. All right, let me save that one and then let me clear all of this out. I'm going to go ahead and just pause the recording while I do this so you don't have to hear me scratching on this. Hi all, so this is number 49 from your final exam review. You're asked to solve for x for the equation e to the negative 5x equals 3. You want to round to the nearest hundredth. Again. And don't round any intermediate computation. So don't round throughout your process. Just leave everything exact till you get to the very last step. Okay, so let's go ahead and get started. First thing we're going to start with is e to the negative 5x power equals 3. Note how I'm giving myself some space like the last problem. Essentially, for 3 and e, you're not going to get a common base for those guys. So you are going to need to use a log here. So step 1, use log or ln for both sides of the equation. Again, it works just as well with either. Typically, if you have e, you would use ln. Kind of a special note about that is that when you take ln of e, that actually equals 0. Okay. Oh, sorry, my bad. That equals 1. I'll just put a quick note here. The reason this is log base e of e. We want to know if that equals 1. Go to exponential form. E to the first power equals e. Check this out. Okay. So I'm going to use log for this one just to stay consistent with what I was doing before. Okay. So then what happens in the next step, you're going to use power rule of logs. This negative 5x power is going to come down. You're going to have negative 5x times log of e. And that's going to equal log of 3. Remember, you're trying to isolate x, so just divide out all the stuff that's not x. So let me put simplify. Or solve for x is fine. Okay, so I'm going to divide both sides by negative 5 log e. So I have x equals negative log 3 divided by 5 log e. Okay. And from here, you just plug in the calculator. Okay, remember an alternate answer for this, if you weren't asked to round, this would be negative 1/5. So I'm taking the coefficient of 1/5 out. And then log 3 over log e, that's log base e of 3 from the change of base formula. So x is negative 1/5 ln 3. Okay. So those are alternate answers, alternate forms of answers. Okay. So x comes out to, we have negative log 3 divided by 5 log e. Negative 0.0414 and change. Rounded to the nearest hundred, you're going to get about negative 0.04. And then you can check. I would say use the exact value you have in your calculator to check, but if you're not sure, you can just use the rounded value. You'll kind of see it. So if I take e to the negative 5 times my answer, let's see. Let me double check one more time because I think I might have done something. Let me pause real quick. All right, you guys, luckily I stopped because this part here is actually an error, and I'm going to use this as an opportunity to go into why, because it's a calculator issue. Totally my bad. Okay, so you can go ahead and save a picture of this if you need to, or you can just fly back a little bit later. Let me erase this. So essentially the problem here is that this takes a long time to erase. Okay, so let me put our actual solution up here. X is going to come out to be negative 0.2197 and some change. So X will be approximately negative 0.22. Okay, and when I check, by putting e to the negative 5 times my negative 0.22 and change that I get from my answer, it does come out to 3. Okay. Okay, so what did I do here? Let me put my error in red. Okay, so when I plug this into the calculator, I'm using a TI 30XS, and I plugged this in. I put negative log parenthesis 3 divide 5 log e. It'll automatically do the caret for you, and then you'll put a 1 here, and then you'll move an arrow button out and then close it out. Okay, what happens there, that's when I get x to be about negative 0.04. Okay, the problem, order of ops, PEMDAS. What this is doing, it's taking my negative log of 3, it's dividing 5, and then it's multiplying log of e to the first. But what I really should be having here is a bracket here. Okay. So the correct way would be putting in negative log parenthesis 3, close parenthesis, divide, put a bracket or a big parenthesis here. Then put your 5 log e to the first. Close your bracket. Okay. So definitely check these things. Use your calculator to practice. And if you do find that you're having issues with this, let me know, because it's probably an order of ops issue. Okay, let's see. So I believe I said I was going to do number 50 in a separate video. So I'm going to go ahead and stop this one and do, I think I'm just going to do 50 separate, and then I'll do 51 and 52.